No, I just got something to work. So.
Okay, so it generates a new link. Fuck.
Oh, perfect.
I have to
Oh, that's
okay. It's the wrong link. So. Okay, we have to go with the link. What's the link?
What's the block? So if you deploy your blockchain, you have to have people that buy into it. So it's organization.
She says it's working.
Really?
Jim, can you see us?
So I'm getting that for them to reposition themselves, they would have to roll out because they have a network of hundreds of thousands of agents and organizations that they create bringing to full. I think like if I was MLS organization, that would be initial because then you get data on the blockchain and protocol and make
the internet cut out.
Or you can connect to Cosmos Gas. That way you on the soul. It's already been. It's already stopped. Okay, great.
I think, all right, we're done.
Okay, so he has to
We're starting! Cosmos and beyond! Alright, this is Zarko. He's our senior research scientist. He comes from a distributed systems background. He has a PhD in distributed systems, so he is helping us formalize Tendermint, the algorithm.
Say hi, Zarko. Oh, we can't hear you. Oh, no, can't hear you.
Maybe it's the speaker.
Let's see if it's muted. Nope, not muted. Boo.
What's everyone's familiarity with Tendermint and with Cosmos? Like beginner level, or how many of you guys are blockchain developers? How many of you are?
I'm a beginner.
You're a beginner. How many of you are academics?
He's academic.
And how many of you guys are just like curious about blockchain in general?
Everybody.
Okay, all right, mostly just curious. Cool. So this is the first time you guys have heard about Tendermint, or no? Where'd you guys hear about us from?
Cosmos. I did heard about Tendermint through Cosmos.
Through Cosmos.
Yeah.
How did you hear about
Testament.
Cosmos?
Well, I heard about them through just following along to other things, actually.
Okay, cool. Awesome.
Okay, Kasha.
Akasha.
Yeah.
Okay. What are you guys interested in? Like, tell me about yourselves. Like, is it interoperability, scalability, using DApps, it's scalability?
Interoperability.
Okay.
UX.
UX. That's interesting.
Building blockchain applications.
Building blockchain applications.
And
So,
blockchain communication.
inter-blockchain communications? Okay, yeah, cool. The protocol. Awesome. We won't get into IBC. We won't get into building dApps on Cosmos yet. But in the follow-on sessions, we'll have more workshop-esque Cosmos academies where you could actually get hands-on, like step-by-step walkthrough of how to build a module using the SDK. Darko. But in this particular one, it's like an open Q&A session, so you guys are welcome to ask your questions as Zarko goes along. I could start us off with like providing a foundation, but you guys are welcome to just like shoot questions whenever they come up. Okay, so I'll give a quick little intro about the Cosmos stack. So how we're different from Ethereum smart contracts is that we've broken out the blockchain layer into two different layers. So the application layer, you can think of this as the EVM. And then the consensus and networking layer, you could think of as this is what Tendermint is, consensus and networking. And with Ethereum and Bitcoin and every other blockchain, Cardano, Stellar, everything, it's one single layer. And what we've done is we've separated these layers to make it very easy to develop on, more developer friendly, and then it's more flexible. It's modular, so that you don't have to build on a smart contract, for example, and compete with other smart contracts for execution and bid up gas prices and everything. So in this way, this is how we tackle scalability with your DApp as a blockchain. And this part is the Cosmos SDK where you like plug in your features into there. So without further ado, Zarko, tell us a little bit about Tendermint and how it works with consensus and networking. And please give us a little bit of context about how this is different from other distributed systems paradigms.
Okay, so. Okay. So, sorry, all, just, is it fine, Shelly, or?
Sorry?
Okay.
Yeah, you get that.
That's weird.
Too much
Technology,
reverb.
Next time we'll fly Zarko in person and he could actually just,
Bingo.
talk to
Well,
you.
that's over.
Yeah, so you know what?
I like your thinking. You guys raise a lot of money, so just fly us over there.
Oh, no, now we can't hear
No, we're still a scrappy store.
What's that crappy headset?
Where's he located?
He's in Belgrade, Serbia.
So,
Oh wait, no, not Belgrade. No.
I will try to talk now and,
Perfect.
okay, so sorry, for all the other guys for the issue with technology we are having. But I hope that we'll be able to hear each other. So, so Christine, can you repeat please the question? Do you want that I introduce a bit the Tendermint, this is idea, or like the general overview?
Tendermint as the idea in the context of distributed systems paradigms that existed before Tendermint.
Okay, so I don't still hear you perfectly, but I will start maybe just slowly by introducing the Tendermint overall, and then we'll hopefully follow on from there.
Okay.
Shelly, please let me know if you guys can't hear me.
Perfect.
So basically, Tendermint is following the relatively long line of research on BFT, Byzantine fault-tolerant distributed systems. Just putting it in a quite now new context, a new setup, and contrary to like proof of work systems like Bitcoin, it is focusing on distributed message exchange for deciding the content on the blockchain. It does this in a quite new and unique way by basically marrying the Gossip protocol with the Byzantine fault-tolerant consensus protocol.
The Gossip protocol is what we refer to as the networking layer, and the Byzantine fault-tolerant proof-of-stake protocol is what we call the consensus layer.
Exactly. So at the Gossip layer, we basically we don't assume single administration domain, like we don't have in a blockchain in a public network like the one Tendermint is will be used in the context of Cosmos network. Basically, we have multiple administration domains, and so we cannot assume that participants have a full network connectivity. So basically, in Tendermint, Tendermint nodes, which we call validator, will connect to a random subset of peers, and then they will exchange the messages about the network. And this is what we call gossip. So gossip is basically really the basic layer of Tendermint, where we exchange messages about the protocol between peers, and then these information are being then propagated over the network. And on top of the gossip layer, we have the consensus protocol, which is effectively a set of rules which ensures that we reach agreement and we agree on the next consensus, and also that that basically we never fork.
So this is very different from Bitcoin, which forks all the time because the network is live, meaning that it's available, meaning that miners are mining blocks asynchronously in their own time, and then they I completely forgot my thought process. Okay, sorry guys. No, I lost my train of thought.
Yeah, so basically the what is kind of very interesting with Tendermint is that Tendermint in a normal operation never fork. So when the transaction is part of the committed block, we talk about transaction being immediately connected and committed, and that's what we call instant finality. And so contrary to system like Bitcoin or other where the forking is normal part of operation, Tendermint as a consensus-based protocol has instant finality. And this is in addition to the property like the lower latency, it is also very interesting in the context of building on top of Tendermint. For example, in the context of inter-blockchain protocol, because once we see transaction as being committed, we assure that that transaction is part of the block, and then we can proceed with whatever we want to do after. And so this is something which is unique to the consensus-based system, where Tendermint is one like strong representative of this kind of system.
So this is one property of a Byzantine fault-tolerant proof of stake secured blockchain because it doesn't fork, whereas Casper, for example, will fork and preserve liveness. Does everyone know what liveness entails?
Does everyone know what fork means in this context?
Yeah. And why necessary fork is bad? Some say fork is good, like having babies.
It's not good or bad. It's a property of decentralization of
Consent.
Yeah.
The nature of it, right?
Yeah, it's a property. So it's different ways to approach consensus.
So you said that it's interoperable with other blockchains.
Cosmos is, yeah.
So I heard about Ethermint. So how does it work with Ethermint?
Okay. How IBC works with Ethermint?
Yeah, I was trying to build on top of, well, I saw Ethermint and I was trying to install it with Tendermint, but I was having problems and I don't know how it works on top of Tendermint because it says Ethermint works.
So Ethermint is being currently under redesign right now. So the software you are using is deprecated more or less. That's why it's not it's probably not compiling. But after we launch Ethermint, we'll be ready. What Ethermint is, for those of you who don't know, it's the EVM basically stripped of proof of work mining and placed on top of Tendermint. So Ethermint is basically Ethereum on proof of stake, Tendermint.
Okay, that's good to know.
Mm-hmm.
When do you expect to launch the new EVM layer?
The new Ethermint.
Yeah.
That's a little bit later down the pipeline, sometime later this year, maybe Q4. Well, after we launch.
Is there someone in particular in your team that focuses on Ethermint, or is it more like
Yeah.
an effort?
There's specifically one person doing the redesign right now, and we're currently still looking for someone to actually implement it full time.
Is there an interest in help, open source help for Ethermint?
Yes. Absolutely. Mm-hmm.
Can you repeat why you don't need to fork? I didn't get it, because a fork is basically just a software upgrade and then not enough nodes upgrading to the new version, right? So how?
Right. So in this context, we talk about forks as in when the blockchain is forking, not for not like a hard fork, for like a software upgrade.
Okay, so you don't have like a fork because there was like two parallel.
No.
Okay, and can you repeat how you achieved it?
It's a property of Byzantine fault tolerance.
Yeah, okay, but you are not the first one who is using Byzantine, so what
Yes.
is the difference?
Yes. Zarko, can you explain why we don't fork?
Yeah. So basically, the one of the property of consensus as a distributed computing problem is called agreement. And by agreement, two processes can't commit different values. And so in the context of blockchain, we are actually committing a next block. And so this is really like it's a property of the like distributed computing problem we are solving here. And so by design of the protocol, we never decide by two correct processes or by the guys who are not faulty actually. We never commit or extend the blockchain with the different blocks. So it's really part of the, how to say, the inherent design of the Tendermint concept algorithm, so we don't have fork. So if fork happens, then this is because we have more than, so just one thing to mention, a very important one. So when we say there are no forks, we mean there are no forks if we have less than 1/3 of the faulty nodes, or more precisely, we have less than 1/3 of faulty voting power. And so Tendermint as a proof of stake system has a concept of voting power, which is attached to every process, every node. And so if we have less than 1/3 of the voting power, then there are no forks. If there is a fork in Tendermint, this means that two correct processes can observe different blockchains or different blocks at particular height. This means that this assumption is broken. So we actually have more than 1/3 of faulty voting power in the system. And in this case, the Tendermint has accountability property, which lets us pinpoint what are the nodes which are misbehaving, so they can be flashed. And then Tendermint can recover from this failure. But it's really, it's not part of normal behavior. So it's really something which is very exceptional, and it's part of the security model, proof of stake security model.
So how we're different from Bitcoin is that all the validators come to consensus on the blocks, on the transactions before we mint or before we commit a block. So in Bitcoin, it's miners individually forming a block, and then they compete with each other, hashing out, doing the hashing to mine a block.
How is this impacting the latency and scalability?
Yeah, exactly. So basically, like in system like Bitcoin, there are no really distributed agreements. So the protocol is purely local. So every node is trying to solve the puzzle. And once it solves the puzzle, it's trying to disseminate the decided block through the network before some other guy do the thing. Because there could be two processes as part of normal operation solving puzzle at more or less the same time, and then disseminating two different blocks through the network. And so this is where you have a fork, because the blockchain is being extended with two different blocks. And this is perfectly normal, it's part of the protocol. In Tendermint, as a distributed protocol, as a really distributed agreement protocol, it's not something local. So the validator, which are nodes which are running Tendermint protocol, exchange messages, and then once it's safe to commit the block, to extend the blockchain, then they all commit the same block. And so this is the protocol which involves communication between validators, and actually it has for termination, to be able to be live and to produce block all the time, it requires that more than 2/3 of voting power of validators are able to communicate with each other in a timely way. And so we do have really assumption on the network connectivity between nodes, because they need to agree what would be the next block.
Can you define termination, Darko?
Yes. So normally when we talk about consensus as a distributed computing problem, we talk about safety and termination or liveness properties. And safety properties is agreement. Like this is what I said before. Like we can't have two different decision values. In our case, we can't have two blocks at the same height. Termination ensures that eventually we do extend the blockchain. So termination said that eventually something good will happen. while safety prevents us from something bad happening. So with termination, we are sure that once we are able to communicate with more than 2/3 of correct validators in a timely way, we will extend the block. And Tendermint is a protocol where we really mathematically can prove that under the assumption we are assuming, there is a bounded period on time when we can commit the next block. And this is what we call termination or live.
So in classic BFT, you usually assume that the number of nodes stays fixed. And that creates all these beneficial properties that you're seeing. Now, I'm not as familiar with Tendermint, but so is that what you simply assume? Or do you have an open network, and in that case, how do you actually deal with that?
How do we deal with the dynamic validator set and rotating leader?
Yeah, I heard it. This is an excellent question. So actually, in Tendermint, it's a fully open network. So the requirement for entering the Tendermint-based network, or at least like, Tendermint is a framework. So we'll, in the context of Cosmos, because this is one proof of stake system, so we can really talk about more detail. So we start with the initial validator set, and then it's responsibility of application to modify potentially the validator set. So validator set is fixed only during one instance of that consensus. So for one height, when we are deciding like what would be the next block, validator set or this process set is fixed. But then as part of the extending blockchain or reaching agreement on the current height, we also potentially reach agreement on the modification of the validator set. So validator sets are part of the normal processing in Tendermint. And so we assume that the set of nodes will be changed.
How do you become a validator?
You need to have the top 100 most amount of atoms, and yeah.
So
Yeah, just to clarify, sorry, yeah.
So if that's the case, then isn't there sorry, we probably shouldn't discuss a tax. I mean, we shouldn't go into the weeds, but okay. I'm
Yes.
trying to understand how that process of determining what the validator set for the next block is going to be, how that is not vulnerable.
Oh, so he's asking about like weighted voting and then century node architecture.
I think if I understand well, the question was how it's like, is there a vulnerability in the modifying the validator set?
Right.
And I think, yeah, this is a very good question also, because we want to change validator set in a deterministic way. Otherwise, we'll also create a fork. So this is also a way to create a fork. And so the way so changing validator set is part of the deciding on the next block. So once we decide the content of the next block, we actually decide what would be transaction which will be executed as part of the next block. Some of those transactions could affect the validator set changes. And we assume that application will have a module, which normally we call, in the context of Cosmos Hub, staking module, which will be responsible for processing those transactions, and then in a deterministic way telling us what are the modifications to the validator set for the next block. And so before you start agreeing on the next block, every node will modify the validator set by applying those changes. And so it's true that in a sense, if this module is kind of not deterministic, then you might have a different validator set, and then you have a problem. But normally this is something very critical. It's you can imagine this being carefully, let's say, checked and agreed by the community or the application which is using Tendermint, so that that it doesn't create problems, so that it behaves in a deterministic way.
got a question. So from an implementation point of view, do you create a document that would have a new validator set in it, then distribute that document to all the existing validators, then have them sign that document, then submit it to the blockchain, and then have a certain piece of code that will execute the new, that'll modify the file system and restart the node to start applying those rules? Is that the correct way of doing it, or is there a different protocol that's designed for deploying new validators, or it's like you have to hand build it yourself?
How do validators grandfather?
So actually it's really part of the online process. So we assume that validator set will be changed quite fast. So they could change every block. In theory, so you imagine the following thing. So Tendermint is about reaching agreement on the set of transactions. And then on top of Tendermint, there is application, which is, as Tendermint is middleware, it's completely application agnostic. And it doesn't know actually what transactions are about. Application will have, as part of its responsibility, to process transactions and also to return to Tendermint modifications to the validator set. So we can assume that we are at, for example, height 5. We agree that about the block of transaction at a height 5, and before, we agree on them, and then we execute them. Application at every node execute those transactions, and as part of the processing of this block of transactions, at the end, it will return modification to the validator set. So Tendermint will take the validator set, and then it will apply them, and in the next height, it will use those validator sets. So it's quite lightweight procedure, if you want. There is no need to sign anything or distribute. So it's really like we have a set of validator nodes, and we have also a set of candidates who want to be validators. And so the validator will be removed or added to the active validator set all the time.
Is there some sample code that shows how to do that in GitHub?
Yes, so you have this because this is not part of Tendermint. So Tendermint is just accepting the changes, but in the context of Cosmos project, we have a staking module. And staking module is exactly doing this. And so there is on a Cosmos, on GitHub Cosmos project, you can find the staking module, and there is a specification and a code which does it.
It's under github.com/cosmos/cosmos-SDK.
So
Have you got that?
So can you query each block for the validator sets, or it's just ongoing? Can you query the block, each block?
Can
for
you
the validator
query
set?
the block for the validator?
What if you want to
sets?
find out the validator set for like 2 blocks ago? Is there a way to query that, or it's just keep voting every time and there's no list, it's not written down anywhere?
There's no what down?
So if the validator sets are just voted for each block and it's not saved, or is there a way to query?
Is there a way to query validator sets from some blocks ago?
What each validator sets are selected?
Yeah, so basically the validator set and validator set changes are written to the Merklein store. And so it's also part of the normal Tendermint API to get the validator set, the current one, but also you can get it from if I'm not wrong, for the previous height. And there is also additional guarantee there that the current validator set is written in a Merklein store, and we have a root hash as part of the blockchain header. And so when you see the blockchain header in Tendermint and you validate the header, then you have also a guarantee, additional guarantee that you will be able to validate the validator set and validator set modification.
Every validator signs every block, cryptographically signs every block, and that's part of the blockchain.
Exactly.
I have another implementation question. Getting back to your very nicely layered architecture with the application and the consensus and the networking layer, practically speaking, what does it take to replace the consensus layer? Let's assume that there are alternative consensus that one might want to use. And you have examples of that in your.
So, Christine, can you just please repeat the question so I'm sure I received it correctly?
If they would like to swap out the consensus layer, can they do that?
And if so, what are the architectural implications and what is the state of readiness of the code to do that?
So right now, we don't have, it would be quite hard to change the consensus protocol in Tendermint as it's not really designed to be, let's say, easily replaced, the core consensus layer. So it is, in a sense, quite localized. So there is a single, it's a core routine, basically, which keeps the consensus state, and it's the only routine which updates the state. So in a sense, the code that is core consensus logic quite localized in a Tendermint code base. But we don't have a, let's say, clean API which would let you just to implement your own consensus and to plug it in. So we might be wanting to do this in the future, but right now we don't support this as is.
So,
That's okay. We need pointers as to where to look for that localized.
Yeah, so so I can provide for this kind of question pointer at the end maybe of the talk, so we also have it somewhere published.
Thank you.
So
Is that fine?
That's great. Thank you.
So the consensus happens at check TX, right? That's where you make sure that everything is the way that it's supposed to be on the transaction that you're submitting, right? So the question is, if you have made a record on the Bitcoin blockchain to say, okay, I have this document that I'm submitting to Tendermint. There's supposed to be a payment associated with this Tendermint document. Here's the document number, and you submit that to the Bitcoin blockchain along with the payment. On the Tendermint check TX, would it be good practice to do a REST call on your own local host for the Bitcoin blockchain to make sure that that payment has gone through? Does that make sense?
So we do have something like this. So just to clarify one thing, check TX is not where we ensure the transaction is part of the blockchain. So check TX is the entry point in the system. So when you, as external client of the Tendermint-based application, submit transaction using Tendermint API, for example, Tendermint RPC, you can submit transaction. You broadcast transaction to Tendermint, and Tendermint will then call application using check-TX API. And application will then deserialize transaction, because for the Tendermint transaction is just a byte array. And so application will verify that it's a valid transaction, and if it's fine from the application point of view, then Tendermint will proceed by dissemination transaction to the other nodes, and then potentially included it in the next block, some of the next block. If you want to verify whether your transaction is part of the blockchain, there is a different API. So it's called broadcast commit, if I'm not wrong. And so we'll also put this after, but like you have basically several options when you are broadcasting or you're submitting transactions to Tendermint using Tendermint RPC. You can asynchronously broadcast transaction, and then you don't care like when it will be part of the blockchain. But then there is a one where you actually wait only for check TX result. And then the last one is a bit transaction, and you're notified once it's part of the blockchain, once it's part of the committed block.
But the question is, does it make sense to check another blockchain like Bitcoin for a record of payment?
Now, this is like inter-blockchain communication is something which is it's kind of a bit more tricky. we are looking into this thing, and we normally talk about this thing in the context of peg zones. So if you have additional systems, additional blocks like this, which is proof of work system, then we need to ensure with intermediary layer that transaction is indeed committed on the proof of work system, because it doesn't have instant finality. Is it still fine or?
Well, I'm not sure I'm hearing the answer. I mean, I get that there's a process that you guys have with peg zones with Ethereum at this point, but what I'm talking about is doing some logic through a REST API, doing a check through a REST API at the time of either check TX or deliver TX to make sure that certain things are in place.
So in the context of ten, you can be certain that something happened. So when you submit transaction, you are sure once it's part of the block that's being committed. Now, when you talk about different systems like proof of work, you don't have that. You don't have that certainty. If you see transaction being part of the Bitcoin blockchain, you are not sure if it's really committed or not. You have probability theory. So normally you need to wait some number of blocks to have very high certainty. And that's why we need to create, if we want to group Tendermint with a proof of work system like Bitcoin, we need to create the peg zone, which would basically provide us with instant finality like property for proof of work system. If we talk about the different consensus-based systems, like for example, maybe Casper tomorrow, you can do this thing much simpler. Because once you see transaction be part of the block committed block, in Casper, for example, you can act upon it in the context of Tendermint. And this is exactly what we are doing in the context of IBC protocol or inter-blockchain communication. But architecture for doing this is more involved, so I'm not sure I can explain it in a very short term. But there is also there is initial architecture and also initial proof of concept work is called PEG, and I also provide also link at the end, where you can see how you can do this in the context of Ethereum and the Tendermint, how you can basically connect Ethereum with Tendermint. For Bitcoin, we don't have such architecture yet, but we work with some people who are from Bitcoin community, and they are very convinced you can also do this. It's just a bit more complex because of the programmability of Bitcoin. It's not so good like in Ethereum because you don't have like the scripting language in Bitcoin is much let's say less powerful, so it's much harder to program it basically to do this kind of.
Actually, our core developer who is building IBC, he's coming soon, sometime. So you could ask those specific questions to him later.
Question, since moving back a little bit one topic, on the topic of performance associated with the validator set and the number of validators, can you speak to the performance of the consensus per block with larger validator sets, and what are the numbers that you can think of are significant with respect to the time? Both I'm thinking in terms of the time to reach consensus, as well as maybe the number of transactions that can be associated with the block, and the throughput of the latency and the throughput of the transaction.
Yeah, so this is a very good question. So as in Tendermint, as I explained, we need to exchange messages between the validators. This has a cost, basically. And so we are not able to do this at a scale, for example, of Bitcoin. So what we are aiming for is hundreds of validators, and for hundreds of validators, we have done some experiments where we have basically the block commit times being in order of seconds, and the throughput was being in the order of, at that scale, around 1,000 transactions per second. Now we are, these days, just about to start, because these are the experiments which are done quite some time ago, and the code base also grow, and also we want to do much more careful experiments and much more detailed experiments. Now, and we are just to start let's say, the set of experiments at this scale. The goal of Tendermint to let's say, the grow up to potentially few hundreds of validators, like I don't know, 300, for example, this is the goal for our next few years. But in addition to the validator, we will basically we assume that there would be potentially thousands of nodes which would be part of the network, but they will not be they will not be directly involved in the consensus. So they will be involved in the gossiping messages and checking, verifying whether the consensus is reached and checking the blockchain, but they will not be able to take protocol messages. And so what we are imagining for the Cosmos launch is a system of 100 validators, active validators in a validator set, and potentially about thousands of full nodes, which will not be, let's say, part of the really core consensus set, but they will be involved in the net.
And what's the best guess for the block time, basically, the consensus time with that scale of network?
So right now we are doing, we have a distributed test network, which are running like already for quite some time now. I think every week or every 2 weeks, we have a potential validators who are doing the distributed setup. And for the last one, there are more than 30 validators. And the block time is, if I'm not wrong, average block time is 3 seconds.
Another question. So when you're creating empty blocks every second, that translates to about 35 gigs per year, right? And is that kind of to be expected to be the growth rate?
If blocks are empty, it's we wait 1 minute for timeout. So it's on for a second.
But in general, so Tendermint is being very fast, and there will be a lot of blocks. So potentially, this would be the blockchain will grow pretty fast. Yeah. So we'll need to figure out the way to compress those data so that it doesn't grow infinite. So right now, if I'm not wrong, we don't have yet in place a way to more or less compress the block. So right now it keeps growing, and so I think like we'll have probably 1 year of time while it's reasonable to figure out this problem. And this is something which is in distributed computing, in this kind of system, there are well-known techniques to basically reduce the blockchain or equivalent of blockchain. Called a state snapshotting problem, where you basically take a snapshot of the current system, and then you're able to persist it, and you remove a part of the blockchain. So now the blockchain context is quite different, but we imagine using one of those techniques to also reduce the size of the blockchain so it doesn't grow. But it is potentially a problem because we imagine new blocks coming every 2 seconds.
So in your proof of liveness, you talk about looking back. So if looking back into past blocks to find, so if you know, since it's not possible with the state you're in right now, looking back into past blocks to find witnesses there, whatever you call it. But what if they're no longer available? I mean, we have an open system where people can come in and out. But don't you get stuck in those cases?
Sorry.
If the honest validators are just no longer part of the network.
Right.
Because time passes, it's an open system, they're just no longer there, doesn't the consensus algorithm get stuck?
So if you don't have more than 2/3 of active validators, then the blockchain just stops. So we don't produce new blocks. So this is part of the crypto economics, or I don't know how to say this, the crypto economics mechanism in Tendermint, where we assume that this is also part of the, like, being validator is a kind of competitive role. And the people who are interested into becoming, or companies, becoming a validator in a Tendermint-based networks, they will want to ensure that they are always highly available, that they have good connectivity with other nodes, and that they are not like offline for a long time. Because there are incentives in Tendermint which will basically encourage people to be alive, and also discourage them from being offline, let's say. And if someone wants to just not be part of the validator set anymore, then he normally can unbond his stake, and then he will be removed and replaced by a new validator candidate. But we now, so part of the ensuring termination of Tendermint is in the, let's say, in the arm of the validators, and they are strongly incentivized being live and reaching agreement, because by being part and signing part of the block, they will gain transaction fees, and also they will get new tokens which are being created in the blockchain.
So validators are not are just elected, and they don't have a stake to lose. So they don't have like in Ethereum, like they have some money that they deposit that they can lose, but in Tendermint they just get selected. They don't have.
No,
There's a staking
They're
token.
staking.
Yeah, you should go with that.
Tendermint is in no way like deposit.
So ask him to go over the staking part of it.
Oh, can you go over how proof of stake ties in with Tendermint?
No, but the staking token is
exactly.
particularly.
So in a proof of stake context, when we use Tendermint, then every validator has some amount of tokens which are being staked, or which are being actually bonded. So this term. And while the process or validator is being part of the consensus or Tendermint protocol, his token are being bonded, and he can lose the token if he is behaved. And in case he doesn't want to participate in the protocol, or there is unbonding period, which is order of like I think the initial value is 2 weeks. And so when you stop being part of the Tendermint protocol, there is a 2-week period in which you can't have your stake basically. So you basically don't cheat in that period. And so to be part of Tendermint, you really need to bond. So you need to have a stake, and so you can lose the stake if you miss it. So this is the part of the security property of Tendermint in the context of proof of stake system.
Yeah.
And also the important thing is that Tendermint is a protocol where there is we reach agreement by voting on a value, and voting power is proportional to the amount of tokens which are being staked. So node who is having more stake will have actually more influence to the Tendermint agreement protocol.
This is a little change of tack, but just like 10 years out, it's like, is Tendermint, like best case scenario, is Tendermint like, is Ethereum gone and Tendermint is like the dominant I don't know. I don't even know how to say it, but is Ethereum gone 10 years and then it's all about Tendermint or what? Sorry about that. That's like not very well worded question.
Okay, so it would be more comparable to ask if 10 years from now is Ethereum gone and the Cosmos SDK paradigm has replaced
Yes.
the smart contract
That's
model.
what I was saying.
Okay.
Wait, Zarko's gotta answer that one.
But like best case, like I just don't understand the vision.
Well, and also, since you brought up smart contracts, can you speak to this? Because we've said very little about Cosmos in particular, and certainly nothing about smart contract support. So,
Yeah, absolutely.
what is the idea, and what support is there?
Sunny. Hey, Sunny. Sunny's one of our core researchers. People have big questions to ask. Some of them a little bit political.
Okay.
But yeah, in the context, if you want smart contracts in the Cosmos SDK, is that what you're asking?
Yeah, and because you just brought them up, and it would be great to hear about that.
Right. How do we do this?
So the idea with in the SDK, the SDK isn't really designed for smart contracting at this time. It's more designed to build like very specific applications. To me, what I see a smart contract is like we started to use smart contracts to build applications. But I think smart contracts should be used like they sound, as like contracting tools. Like it's something where you need users to like create contracts and like put them on chain.
But is there then in the envisioned SDK or progressing SDK some notion of being able to record state associated with accounts?
Yeah. I mean, so we already have the ability to do this. What the SDK is designed to do is it says if you want to build an application, you put all the logic of your application. So let's say I wanted to make a prediction market, or if I wanted to make a decentralized exchange, I build all of the logic I want for that application and put it on the blockchain, and it's its own blockchain. The key is you don't want users to be putting arbitrary scripting or code on the chain. Like if you wanted to do that, then you could use something like Tendermint, which is
but there's a very, very powerful property of the smart contract model, which is this ability to attach state to accounts on the blockchain.
so you can already do this with the SDK.
How do you do that? That was really the question was going on.
So if I wanted, when I'm making my application, right? If I'm adding, let's say I'm doing this prediction market, right? In my application logic, I'll attach like I can have reputation associated with a certain account because that's something you need in a prediction market. And so this is like something the idea is like it's the application developer that's choosing what state, like what the properties of an account are, rather than allowing users to arbitrarily choose like.
Yeah, but without that mechanism, then you have to put that state somewhere, and then you're leaving up to the application developer to decide whether they write that directly into the blockchain or they have some separate database they store that in, and then you get into all of this fuzz that's currently well defined in terms of the smart contracting model. And I'm not trying to advocate for it; it's just that is true in Solidity today on Debian.
I don't quite understand what.
Well, if you were to take that away, you'd be back in as you're saying. I think each application is going to have to take care of the storing of what I'm calling state with blockchain accounts somehow. And they're either going to write that into the ledger as part of a transaction, or they're going to have a separate application database where they put that stuff, and then you're losing some of the power. Right?
So maybe I can phrase it like this. So maybe I can talk to you a little bit about how the APCI and Tendermint core and an application works.
That's great.
So what Tendermint core does is we have this like separation between what we call a consensus engine and a blockchain application. So what a blockchain application does,
Thank you, Ben.
so what a blockchain application does is it keeps track of the state, and the Tendermint core basically comes to consensus on a bunch of transactions, and then once those transactions are confirmed, they get sent to the application, and the application processes some state, and then it sends the hash of that state back to the application where it comes to consensus on it. And so what the Cosmos SDK is it's the framework for building the application. And so it comes with a lot of like tools for like database tools, like how to merkleize your data stores, how to very efficient. We use IAVL trees. So we come with the logic to do all of that. And so that's sort of what the SDK is. Yeah, so that's what it's giving the developers the tools for how do they manage that state.
So actually on this, just to be very sure, so Tendermint itself, the Tendermint core does not have a notion of an account, or does it?
Tendermint core does not know what an account
So
is.
account is application level, let's
Yeah.
say, on this case.
Mhm.
Now, tell me one more time then, how does staking work? So if you're a validator, then you don't have an account, is it right? What do you have?
So
Like, what is it?
one of the things that gets sent between ABCI over ABCI is Tendermint core just knows that this is the list of public keys that are the consensus keys for this time.
So it's kind of like an account. So the public key, if you will.
Yeah, all the Tendermint core knows is the public key and the voting power. It doesn't know like stake or it doesn't know about coins, it doesn't know about slashing, it doesn't know any of that.
But the public key is the same as it. I mean,
Yeah, it doesn't know about
public key. I mean, the Ethereum account is a
Sure.
hash of a public key. So if
Sure.
you have a public key, so you kind of have an account.
Sure, it's fine. We can call, if we want to call that an account, yes. But it doesn't know about the coins or anything like that.
That's right. But it knows about an account, meaning the public key.
Yeah, it knows about a public key.
But it
And-
only cares about those of validators then.
Yes, it doesn't know about anyone else.
Okay.
And so what you can do is the application can basically, so Tendermint core is just asking the application, tell me what the current validator set is, including the voting power. So the application can choose to like do this through proof of stake or proof of authority, or you can even do something where like I submit proof of work and like the more proof of work I submit, I get more vote. That's what, so, Tendermint core, just, you send it an array of validator, pub keys
And the ABCI, is that how Tendermint queries the application level for a validator set? Or does it get pushed down or? That's the part I wasn't clear.
Sorry, say that again?
How does Tendermint core then get a hold of the set of public keys for the validators? Is it a query it queries the application?
The application doesn't push to it.
The application pushes it.
Yeah.
And then that I see, and that's what Zart was talking about. Okay, so the application is in charge of the consensus on what the validation set is, basically.
The application is responsible for how to
They always
process the transactions. So the application is a state machine. It knows the current state. Tendermint says, here's a bunch of transactions, apply and send me back the end state.
But with respect to the set of validators, how does it know what this, or how does it?
The application is who manages what the set of validators are. Tendermint, for example, the Tendermint, Tendermint, like, it just listens to what the application tells it. If the application wants to change the entire validator set every single time, you could just say, here's 10 million people, let's just like have randomly pick 100 of them, right? That's what the application can do, and Tendermint core is not trying to say, it's changed by more than 1/3, or it doesn't care about any of that.
Okay, so Tendermint doesn't prescribe how applications should, or doesn't provide a framework for applications to establish the.
I'm not sure if it helps, but the thing that you have to keep clear is that Tendermint is just a consensus protocol. And so.
But the validator set is a core,
Well, that's what I was gonna say.
No,
You can all
the
those
validator set is
programs.
basically part of the application state. The coin is actually part of the application state. Tendermint
Yeah, but
core
what you
is just.
decide to be the validator set is inherently impacting how the consensus works
Yes.
by design.
Well, it is,
You
but-
can almost like make your own.
Well, yeah, but if the application determines kind of with each round of voting what the validator set is,
Yeah.
and the protocol only cares what the fixed set of validator
What
sets
the
are
deciding
at a
sets
particular
are.
block height. Basically. But I don't know if that helps or not, but it's again, the thing to keep clear is that Tendermint is just the consensus protocol, like equivalent to proof of work in blockchain, or in Bitcoin, sorry.
Equivalent to
Ish,
Nakamoto
ish,
consensus.
ish, yeah.
So there's this thing about like Nakamoto consensus and EFT consensus, and then there's like proof of work and proof of stake, and these are two different axes. You can do like proof of stake Nakamoto consensus, which is kind of what Casper is, or you could do proof of work Nakamoto consensus. You can do proof of stake BFT, and no one's actually done it yet, but from theory you can do proof of work BFT, which is kind of what I was describing a minute ago.
But that kind of relates to her question about
Well, yeah, I mean, in
about
the
the
limit, you
smart
can-
contract. I would actually, to make a point, I would kind of state it in a different way, maybe too extreme. There's nothing special about smart contracts. the idea of actually putting the code on the blockchain and having it execute on the blockchain is interesting, but that doesn't make it necessarily any more secure than
Just a special state machine.
because what the whole system is just a way to manage a state machine.
Yeah.
And so in the case of, I think the thing that's brilliant about what Tendermint does and what they separate is to separate out the state machine, the logic of the state machine.
Yeah.
And as long as everybody's state machine is consistent, then you can reach consensus on the blockchain. Now it's possible that people could write bad code and the application could never reach consensus. That's one of the things that the VM, the Ethereum VM kind of helps mitigate this.
One of the
But you
good
can still
things
write-
that which like, Tendermint does do, and Ethereum did this as well, is the application does tell back to Tendermint core, this is the hash of the state. So the nice thing is if like an application is like buggy and is non-deterministic, right? And two people and like half the machines execute one way, half the machines execute a different way, that it'll like halt everything because they'll try to pass back the app hash and they won't be able to come to consensus. And so that's good because in Bitcoin, I think one of the worst decisions that like Satoshi made, I think the biggest problem was he never committed to the state. And because of that, for all you know, if it diverges, it might be a very long time before anyone even realizes. Because you're not trying to come to consensus on the hash on the state.
But to me, that's kind of part of the brilliance of Tendermint and Cosmos is that there's no way that large-scale real-world applications are going to be written in Solidity on the Ethereum blockchain. I mean, that would never scale. It's never going. No one's going to rewrite the entire world in Solidity. So you have to have a way for applications to reach consensus, but with any programming language that you want.
Well, and just one more small note on this consensus design, albeit the point of Tendermint, as you said, is to provide for the consensus, but in reality, because the application can control the validator set, you could in fact take the extreme and say that there is no validator or one default validator and then do your own consensus to drive it, right?
Well, yeah, I mean, that's part, but part of what I believe
Which
about.
might be a good thing.
Yeah, no.
It's very flexible.
Well, that's the thing. I mean, what Cosmos envisions and what Tendermint envisions is a kind of ecosystem of many blockchains, which I think is really the only way that applications are going to be built.
Well, that was my original question was, can you swap out the consensus and how you do it architecturally? You wouldn't even necessarily need to replace the Tendermint consensus. You just control it in a way that makes it almost.
I think that's a better way of thinking about it because when you said that, Hyperledger has this concept of kind of swappable consensus engines, and that just makes me extremely nervous because probably the trickiest part to get right and to keep safe is the interaction between the consensus engine and the application. And so if you have a good consensus engine and it's well integrated with the application, you really need to keep that tight. And the idea that you're just going to like swap consensus engines out and kind of that makes me very nervous about Hyperledger.
So vice versa, that's the area, the greatest research, you need the greatest flexibility for go forward, right? And so the point is that I think this architecture permits that on top of what you call the Tendermint.
Yeah, I think with the API is it's an interface that you can actually you could swap out Tendermint core for like Honey Badger core as long as it meets that.
Or just keep it and drive it, as almost a.
Yeah, absolutely. I mean, just as we said, by nature of the fact that Tendermint is just a consensus engine, in theory, it can be swapped out. Yeah. But I like what Mark, what has been said about, well, it's not really there yet. And the reason I think it's probably that way, the hard work here is to just get proof of stake to work correctly and scale. And then once that's in place, then I think that maybe you go on and start, doing fancier and different flavors of proof of stake or different things.
I got a question for you. Yeah. So let's say, here's a case scenario. Let's say I have property and I want to transfer title to you, and that title is recorded on the blockchain within Tendermint. Let's say the payment is in Bitcoin. So let's say I have your public key and I do a deposit to your account, let's say 10 Bitcoin for a property. Then I include that transaction in the Tendermint document that gets submitted to be validated as a transfer of property to you.
Okay. So you're basically trying to use a Tendermint chain as a record, so you're doing Bitcoin transfers.
So I'm recording that a payment has been made to a specific address.
So it's like a ledger of you could have gotten that data from scanning Bitcoin, but you want like a more efficient way to
Well,
scan.
the idea is then the document that you submit to Tendermint is a JSON document, which would contain my name, your name, the transaction on the Bitcoin blockchain.
I see.
Maybe some other parties that have signed some this process as well. So basically, the validation would then within your check TX or check delivered, you would say, okay, do a localhost REST request to say, was that payment made that you say it was made in your document, in your Tendermint document?
One of the things with IBC is you can actually use it to like you can do like proof, you can add the IBC proof that look, this transaction actually was in the Bitcoin blockchain.
But it's not there yet, right? So I'm just saying, like today, if you submit a JSON document with a reference to it, would it make sense that let's say you have 100 people that are, let's say it's a real estate industry, and you have 100 validators, all of which are running Tendermint nodes along with Bitcoin nodes that do their own localhost check for. Is that good practice? Or
I think for now it's a nice hacky solution. At some point, I think at some point we will need we'll probably have a proper Bitcoin peg zone running. Actually, hold on.
You asked this question previously, and I think so. It relates to the idea of the application logic. So you could have an application where the 100 different validator nodes all calling out kind of on their own to some external API, get some piece of information and incorporate it in the business logic. And as long as they all end up agreeing, that all happened correctly, then they're going to sign the transactions correctly and move on. Now, the reason it could go.
The model of doing that is actually a very good way of doing it. So
I think it's a very bad way. It's a big impedance mismatch because the power of Bitcoin is large numbers. The Tendermint style is validator set with just small numbers. You can easily attack 100 Bitcoin nodes. If each validator you have 100 validators, if they run their own Bitcoin nodes, those local Bitcoin nodes aren't reliable. You want the power of the Bitcoin. You can't ask your local host because it's easy to attack. You have a little denial of service, you're behind 3 minutes, you're all decoupled from the network for 5 minutes, 100 minutes, you buy a house based on a just tiny denial of service of 100 computers.
Oh, but then they'll just say that, look, we don't have the data, and so they'll take that.
Yeah, forget about it. Maybe not checking Bitcoin locally.
They're in a different world. Any 100 Bitcoin nodes can make them think in a different world.
How do you make them think that they're in a different world unless you pull them off a massive double spend attack?
For 100 nodes, simple denial of service, they're offline for 10 minutes.
If it's offline, it's okay because then the people who are telling the Tendermint chain, so the Tendermint validators are looking at this Bitcoin thing, and they're going to say, look, everything we don't know what the current Bitcoin state is, so we're stopping all
You think you know. You're a Bitcoin node. You think every Bitcoin node thinks it knows.
No,
I mean,
so it should only be acting on things that are 6 blocks.
100 Bitcoin nodes, trivial to attack.
No, it's not trivial to attack 100 nodes by making them think there's a confirmed block that's 6 blocks deep.
I would agree with you, and I would buy a house or 100 houses with this system. I would be good. That's good. I'm gonna say it's good.
Okay. Okay.
It's the power. That's the thing. I think the power of a system with the validator set is in the validator set, and you don't have to have that many. And you have this third Byzantine system, right? That you can know. But
let's take an example of an exchange, right? If an exchange, how do you try to double spend an exchange? You have to have enough hashing power to do that, to cause a fork to get to the point where they think it's confirmed, so let's say 6 blocks, and then you need a double fork and you have to outpace the entire network. That's a double spend attack. You can't just DDoS an exchange and trick them, because if you DDoS the exchanges like Bitcoin nodes, they're just going to say, hold on, why haven't we gotten any new blocks lately? Let's cut off all the transfers on our exchange. We're not letting trading happen because we have no clue what's the current block.
But that logic is not in Bitcoin. That logic is somewhere else.
Yeah, that's what I'm saying. The Tendermint chain would have that logic.
That's smart.
Yes, of course.
That's what I'm saying.
But isn't that why you said you're going to be running both Tendermint and blockchain and Bitcoin at the same time?
Yeah,
I agree.
They would all be part of the same protected cluster behind the firewall.
Yeah.
So in terms of denial of service, there's ways of dealing with that.
Worst, in a big network, the worst thing is segregation, right? So you can segregate networks, and they all think they know what they did because they all have mined and info. So if you segregate, to network simple narrow service attached to the layers. Anyway, that's what my point is. The Bitcoin network doesn't have a mechanism to figure out, oh, I'm segregated from the other network. They just think they know, right? The Bitcoin node isn't designed. However, if you're an exchange, you better do have what you said.
Yes.
And anyway.
Their his validator set, whatever tool you use.
So you need to have an external tool that checks with the rest of the network to make sure you're not being cut off.
Well, I would have imagined that before you do that final title transmission, you would ask, there would be another application API through which you ask, okay, is it at the chain is it at the level that I think it's going to be? Is it the height? Has it received X number of confirmations?
You need to ask the rest of the Bitcoin networks. You need to have a kind of, yeah, we got one.
We could table this discussion for later, but we have about 15 more minutes of this meetup. And I will take a question from the Telegram group and ask Zarko to answer it, if that's okay. So the question is, as opposed to the current deterministic round robin validator selection scheme, did we consider other randomized schemes, a la Definity, for example? Zarko.
So right now it is deterministic because we consider that we deal with the potential DDoS attack with the entry architecture, which is so kind of at engineering level. But we imagine, I think we might be in the future seeing also more like randomized proposer election, like maybe. So to make short answer, right now, don't do this thing. In the future, we might be doing this, but don't see this. In my view, it's not something very, very, let's say, game changer. So I think there are potentially some other changes in the Tendermint platform, which we'll be doing for let's say, better performance, some higher throughput or smaller latency. But I don't see the leader election or proposer election, whether deterministic or randomized, as kind of a big game changer.
Okay, thank you. More questions about Tendermint?
I just want to make one comment because there was a discussion of the replaceability of Tendermint consensus with something different. So the BSD consensus protocols are quite tricky algorithms. And first, there are like the design space is quite small in a sense. If you talk about partially synchronous system model, which is basically what like wide area network are quite well modeled, and Tendermint is designed in that model. The design space is quite limited. And so picking a different algorithm would not necessarily, look very different from Tendermint. And but implementing different algorithms correctly is a big challenge. So the value of Tendermint is there is a value in Tendermint algorithm because it simplifies some things with respect to the state of the art, like PDFT, for example, or DLS, because it's simpler to understand, because it's relying on the gossip networks. Some things are done in a simpler way. But the biggest value is implementation of it. So when you design the consensus protocol on paper, going from the algorithm to really production-ready system is a big challenge. And we don't necessarily, in general, in distributed computing community, know how to do this thing. So this is this is something which I think it's very important to have in mind. And although I do imagine making some changes or using some, let's say, slightly different, I would still do it in the context of Tendermint code base because it's quite stable. There are lots of tests. There are a lot of people already, code review it. There will be a formal specification in the following week coming up, And then there are also people who will be formally verifying the algorithm, really like automatically formally verifying the code base and the algorithm itself in the following month. So there is really deep value in the code base, not just the algorithm itself.
Since I'm the person who asked, I totally respect that. I think the main point there is obviously there's huge innovation happening around beyond proof of stake kind of models and that are in the Byzantine fault-tolerant class. And as a result, one if you're really being responsible to the future, one needs to be able to think there and obviously implement them correctly. That's always asking for guidance on where in the code would be the logical place to place new state-of-the-art consensus.
Do you want the link?
I'm not. I haven't really. Maybe please take a mic because I think I haven't really correctly heard everything.
We have a Tendermint BFT blog post with all the links in there.
Okay.
But I mean, yeah, it's like I said, if you can build your consensus engine to meet the ABCI spec, then it will you could swap out.
It will work.
Yeah, you could run Cosmos SDK all over this other whatever consensus engine you want as long as it meets the ABCI spec. And I'm sure over time we'll see more consensus engines complying with the ABCI spec.
So
Don't say there would be just Tendermint. It's just that that these are not things we expect that everyone try out to come up with his own consensus engine. So this is something which I don't see, let's say, is very realistic. Now, of course, there will be alternatives, but I think that there is implementing these kind of systems and testing them is quite challenging. And so that's why if there is a good code base, we like to think about Tendermint as a platform which would let people in the future design their own consensus protocols. So I would more think about the platform that way. So we'll really try to emphasize putting things so people also from academia can have a perfect playground to try out new ideas in the context of real systems. And so this is really one of the not short-term goal, but mid-term goal to make Tendermint platform or Tendermint code base basically ready to try out new ideas very easily.
GitHub.com/Tendermint/Tendermint.
Fork and split.
So Tendermint is not a distributed ledger,
No.
and there's no way to store anything onto the blockchain of Tendermint, to the blocks of Tendermint.
Wait, so Tendermint is just a consensus engine.
Right.
You store, and what gets stored on the Tendermint ledger is transactions. And then what gets stored in the application state, in the state of the application database, that's, you can put any sort of state in there.
So also, I tried Notion.js, and it says that it runs on Tendermint, and I guess Tendermint is installed when you install Notion.js.
Mm-hmm.
And so if I run another Tendermint by itself, is there a way, is that would it conflict, or is that like you can run many?
Yeah, I mean, you just have to set them up onto different processes and so you have to make sure you set them up on the right port. So basically, Tendermint and Tendermint's running on its own process, and it's talking to the application on a different process, and it's using WebSockets to communicate between them. And so you just need to make sure if you have two Tendermint chains running on your system, then you want to just make sure each application Tendermint pair is talking to the right one by setting the ports correctly.
Is version 0.14 and 0.14 and 0.19, are they supposed to be able to synchronize with each other?
I don't think so.
And do you know when that kind of break off, what's the, right now it's 19.3, right?
whenever we hit 1.0.
So at that point, is it going to be kind of locked in where you kind of you can kind of expect future?
I don't know, Zarko might know more, but I don't really touch Tendermint core too much. I focus mostly on the SDK. So maybe Zarko knows.
So with the question when we'll stabilize on the Tendermint API, or
the question is there at some point we will like promise all forward compatibility or backward compatibility?
Yeah, definitely it will happen, but we are still in a kind of relatively fast-paced mode, and so we're still making breaking changes, let's say, quite from time to time. So, but definitely the goal is to have full compatibility at some point. But maybe I don't know, maybe one would be the thing, but right now it's not a goal. So right now we are trying to make the code base as robust, as performant as possible, and so we do indeed break. We are not very compatible.
So for an example, we actually did make some changes to the ABCI spec, and Tendermint 0.14 was like an old spec, and the latest one is on the newest spec. And so our Ethermint code base is actually kind of like, we put that off to the side for a while, focusing on the SDK and hub launch. And you can't actually run right now Ethermint on the latest Tendermint. You have to use 0.14. So that's an example.
We're running out of time. We've got maybe 2 minutes left, so we could take 2 more questions.
Okay. If I want to write an application for EOS and Ethereum, and they need to be mediated by some middle appware. If there's data that's important that I do not want to write on EOS or on Ethereum, and that I also want to be decentralized, there's no way to put it on Tendermint.
I'm not sure. I don't fully understand the architecture you're trying to go for, but no. So the idea is yes, you can put data on a Tendermint blockchain. All I was saying is that the data doesn't go in the transactions, are what goes in the Tendermint core, in the blocks, and then the data goes into the database of the application. This is how
But I want it decentralized, because now if I put it on my app,
yeah,
be centralized.
No. So everyone who's running a node are running both of these pieces of software. So this application is running on everyone's computer. So it is, the data is still decentralized. This is like the same way like every blockchain works. For example, Ethereum as well. Like what it does is it's all the blocks that are being transmitted are just the transactions, and then everyone applies the transactions and keeps the database on their own machine. They don't every block, they don't broadcast these 500 gigabytes of data every time. You just broadcast the transactions and you build the database on your own machine by executing all the transactions.
So how would I make sure that, let's say there's a buyer on Ethereum and there's a seller on EOS? Then I want to make sure that the transaction is provable and immutable. How would I, is that supported on Tendermint? So the data will
yeah, so this is something that IBC is designed to hopefully solve to do, is that you should be able to prove the existence of some data on another blockchain. So I could say, prove to me that this transaction exists in Ethereum by getting a Merkle proof in the transaction tree, or I can say, prove to me that this account has this balance by giving a Merkle proof over the state tree. That's sort of the goal. And you can do these proofs. And how our Cosmos SDK, it does it doesn't just put the state into a database, it also creates a Merkle tree for that state, and so you can do these queries, efficient queries. and that's kind of like what I was saying, was the issue that Bitcoin didn't do. It didn't merkleize the state, and that makes it very impossible. Like, for example, I want in Bitcoin, if I wanted a proof that like a transaction is in the UTXO set, so the UTXO, like the set of unspent transactions so far, outputs so far, there's no way for me to do that without like scanning over the entire chain. But if you merkleize the state, I can give you a simple, like, efficient proof saying, look, here's the latest block header, and look, here's this transaction. It's in the state tree. It's unspent. If Bitcoin did that, it could be, you could do a lot more cool stuff.
One final question. That was you.
Oh, I didn't hear the. I mean, when is Cosmos going to go live? End of June is what I heard.
June or July?
Definitely, hopefully, by then. Definitely, maybe by then.
Zarko?
Jay said he'd shave his head if we don't launch by the end
I
of
heard
May,
that,
and I
yeah.
told him that's like, yes.
Just shave your head now.
I'll shave my head if we don't launch by the end of July.
Okay.
That's what I said.
Are there like roadblocks or like
It's just code, man.
It's code, but it's also financial code, and it's also financial code on an immutable like system. It's like,
don't get it wrong.
yeah.
No question.
The roadblocks, I don't think there's many roadblocks at this point. It's sort of a, what's left to be done is, I would say staking is like 75% done, and governance is like, also 75% done. Those are just like two modules that we have finished. Tendermint core is basically at like a point where it's like, we're not making any major changes. It's just like, Tendermint core is already going through auditing and stuff. So that's good. The SDK is pretty stable. Just a matter of like creating those final modules. I believe I think that we should probably launch without IBC. Maybe even if we have the code ready for IBC, I think it makes sense to launch without it. What?
We won't.
Yeah, we won't, because like even if the code is ready, which it hopefully will be, one, there's no other chains to connect to. No one's going to want to connect to the hub in the first month if no one else has like IBC compatible chains. If we put an IBC a month later, it's okay. And also it's like, we're also already in the process of launching the first Tendermint proof of stake chain, first chain with like governance built in. It's like, those are two hard things. That's like not add a third hard thing in the middle of launch, and like just more things go wrong at launch. But yeah, so just sort of that. What I was actually kind of worried was I thought that like fees and gas counting would take a lot longer than it, but like Chris just like hammered it out in like 1 week, and I was like, whoa.
Chris is here, and our IBC developer is here as well. You could, they're in the background, but for people who have IBC questions, you could meet June. He's like 18 years old and pulled him out of school. He's working for us now. It's great. Yeah, he's like a prodigal developer.
Another interesting thing, by the way, we were talking about this smart contracting. So one of the reasons we kind of like left Ethermint and like just like let it die for the moment is because the current version of Ethermint is running get on top of like running get as the exception. Our new version of Ethermint, what we're trying to do is try to build the EVM as a module in the Cosmos SDK. And so, because for Ethermint, it needs a lot of the similar stuff like staking, governance, IBC. And so instead of trying to figure out where to insert these things into get, let's instead figure out how to take the EVM and insert it into the SDK. Because that's really what we're looking for. We don't necessarily want all of the stuff that Get has. And so we're looking at the Ethereum Classic guys have this code called Sputnik VM, which is it's like a pure EVM. So we're thinking of like using that as possible.
That's a Go bank as well.
It's in Rust, but it has Go bindings.
Cool. Thank you everyone for coming. Thank you, Darko. It's like some late, absurdly late time for him. So good night, Darko. Thank you for taking the time.
Thank you, guys.
Thank you. Bye.
See you.
Good luck.
I don't have no idea. I don't really
So basically communication.
Excuse me. Thank you.
I'm a CTO.
No. Oh, photon is Adam. No, not yet.
Yeah, no, there's a number of kind of competing projects that kind of trying to improve these things, right? There's EOS and there's,
No, we're launching this year.
this year.
It's been good and it's been great. Shelly, operations manager. Bye.